Okay, so the last remaining operation that we can do with polynomials is to divide them. We've learned how to add them, subtract them, and multiply, but we've left division for last. So for 4.8, that's what we're going to address. And kind of like multiplication, we're going to break it up into two categories. Let's deal with monomials first, get a feel for how we do that, and then we'll build to binomials and trinomials and what have you. So to start with, when I divide by a monomial, notice that in all these cases I have a bi divided by a binomial, I have a trinomial divided by a binomial, I have another tri divided by a monomial, and then right here it's written a little differently, but I've got a 4-term polynomial divided by a monomial. So we're looking at all those cases. And basically what we're going to do here is think about what it means to add or subtract fractions, right? When I do that, we can see that this actually is just two fractions written as one, right? So if I had given you 12x over 3 plus 24 over 3, the idea is you get a common denominator, keep it, and then you add the numerators. So I'm just going to do this in reverse. Since I already have a fraction and it has the same denominator, I'm going to break it up into the two fractions that it is. And therefore, once we do that, we can see we're basically down to simplifying or dividing two separate fractions. And in this case, 12 divided by 3, well, that's 4 times x. And then 24 divided by 3 is 8. And there's our final answer. So 12x plus 24 over 3, that result is the 4x plus 8. And so that's basically what we call our quotient. All right? And so keeping that story up. So here we basically have 3 terms all divided by a particular monomial. So we can break this up into the 3 fractions that it represents. All right, and so again, if we worked in reverse, if I was adding and subtracting fractions, I have the same denominator, I would keep it and then just subtract and add numerators. So I'm just basically using that idea in reverse. And like over here, you can see that we have 1, 2, 3 fractions that essentially need to be simplified. Here, 12 divided by 4 gives us a 3. And then, you know, some of you might see this as a just dividing out an x. But let's go ahead, you know, we haven't used this in a while. That's basically my quotient rule, 2 minus 1. It's a minus 1 by there. Minus 6 divided by 4, well, that reduces to 3 halves. And then x divided by x, right? Well, technically speaking, it's 1 minus 1, but you can see they go to 1. And then over here, this is a little crazy, but 4 and 18 share a 2 in common. So 2 goes in there 9 times and twice. So we have a 9, and then unfortunately that x doesn't go away with anybody. And so cleaning up my cleaning up my exponents, that x down below, right, there would be basically be our answer. So this first fraction reduces to 3 times x. This second fraction, the x's cancel out, or that's x to the 0, which is 1, which is 3 halves. And then reducing this fraction, we have 9 on top and 2x down on the bottom. And there would be our answer. All right, so essentially, again, what we're doing is dividing by a monomial. Break it up, simplify your fractions, and that's what it comes down to. Making things a little harder, we have polynomials with several variables. We have a trinomial divided by a monomial, and we just basically use the same trick. There's 3 fractions all at once. There's 18a cubed b over 2ab. We're subtracting that 10a squared b squared all over 2ab, and we're adding that to 12ab cubed all over 2ab. So break it up, and again we're back to simplifying fractions. 18 divided by 2 is a 9. A into a cubed, right? Well, there's 1a and there's 3 of them up here, so I'm just going to say that's a squared, although technically speaking, again, we're using that quotient rule. B divided by b cancels out, or divides out, excuse me, and we're left with 1. So this fraction here simplifies to 9a squared. What about the next one? Well, 10 divided by 2 leaves us with 5. A divided into a squared, well, again, if you think in terms of our quotient rule, that's a to the first power. And then b squared divided by b, again, that's 2 minus 1, which leaves us with b to the first power. So there's how that fraction simplifies. And then last but not least, 12 divided by 2 is a 6. the a's divide out. I have a b cubed divided by b, so there's 1b and 3 upstairs, so we're left with b squared. Or if you wanted to use the quotient rule, right, that's b to the 3 minus 1, which is b squared. And so there is basically the quotient for that fraction when I take that trinomial and divide it by a monomial. 4, written a little differently, but we're still taking, the parentheses are important here. I'm taking this whole 4-term polynomial and dividing that by that monomial. And so if you rewrote this, this is like saying 20x cubed minus 15x squared minus 30x plus 10. And then each one of these gets divided by 5x. So just following what we did up here. And then we're back to simplifying fractions. So 20 divided by 5 is 4. There's 3 x's up above and 1 below, so we're left with x squared. Or if you want to use your quotient rule, right, that's x to the 3 minus 1, which is 2. Minus 15 divided by 5 is 3. X squared divided by x, well, there's 2 x's and 1 x, so the x's cancel out. Or using my quotient rule, right, that's x to the 2 minus 1, which is x to the first. Over here, 30 divided by 5 is 6. The x divided by x is basically going to divide itself out, leaving us with 1. And then last but not least, 10 over 5 gives us a 2. And then that x basically stays on the bottom. And so there would be our final answer for number 4. So that is how we start our division process. We start by looking at dividing by a monomial. And as you can see, what it basically breaks up into is to mini fractions, and then you simplify all those little mini fractions. So things are going to get a little tougher when we move away from monomials, and we'll start seeing that in the next set of videos.